Okay, here we go. Third time's the charm. So I got a new computer. Hopefully this will work and I can get this posted within the hour. This will be the lecture portion of lab, the kind of the theory and the things we need to remember before we actually go out and do things hand by hands on. So this is for lab dairy nutrition, lab week 1. Um, so one of the things I want to get started with is kind of talk about some of my expectations and some of the things that you can know me better so you can understand how I work and the way I do things. So, my expectations for this semester, I will be addressed as Dr. or Professor Mooney. Um, that's the way we do things in the dairy program. I will try to address either by a Mr. or Ms. as we learn names. Always takes me a little bit. I'm not real good with names, but I try. Marsville hired me not to teach, but to help you learn. So that puts the emphasis on you. You have to put in the work. You need to do what needs to be done. If you have questions, you need to speak up. You need to ask them. If something doesn't make sense, you need to let me know. I can teach anybody anything or help anybody learn anything, but I need feedback. So if there's a concern, a question, please ask. Expectation, I will be asking for your very best. That is different from for each of you. We want you to improve, get better as the semester goes on, whether that, and then beyond that, 2 or 4 years, however long you're here. I want you to try. I want you to go out and make mistakes. That's the way we learn. Sometimes doing things wrong is the best way to learn something. So please give that a try. Getting to know me, what you should know about me. If we go through the first day form for me, I have a lot of different jobs on my resume, but probably the most relevant to you is after 4 years of college, I went back to work for my dad for 5 years. That gives me a hugely different perspective on what you need to know because I went back, I had pretty good grades coming back. I was like, well, this is not the way I was taught, or this is not applicable immediately. I had to translate things into a way that was applicable to a day-to-day working farm. There were a lot of things I learned that were irrelevant, and there are things that I wish they had spent more time on, and there are things I had to teach myself. I know what you need to know, and I'm going to get that to you as quickly as possible. I've got a PhD in dairy nutrition. Took me a while to get there. I came to it later in life. I think that gives me a perspective that's helpful to the students. As a person, I tend to be a generalist. I like knowing a little about a lot of things as opposed to knowing a whole lot about one thing. I'm a journey person more than a destination. I try to do things right, and hopefully the ends will take care of themselves. I don't believe in doing anything at all to achieve a particular desired end. I tend to be pretty even keeled. I don't have big mood swings up and down, particularly as I work. I'm not prone to hyperbole. I tend to say good, and that's about as high a compliment as I usually give anybody for that matter. If you're looking at introvert, extrovert, I'm probably more of an introvert, although tests say I'm an extrovert, but I am an introvert in the sense that I think before I speak. There are a lot of different introvert, extrovert definitions, but that one seems to fit, I think, in my head. So if you ask me a question, I'm going to think about all the possibilities, all the answers. If I don't answer right away, my face is going to start doing all kinds of weird things as I think. That has nothing to do with you. That's just the way I'm wired. So don't take it personally. Enjoy the show, I guess. Enjoy the funny things that are happening to my face until I come up with an answer. I tend to listen more than I speak. That's just kind of the way I grew up, the way things were. But I'm not shy. I tend to say things that surprise people. I tend to be very direct and very blunt as I move forward. I'm horrible with names. Traditionally in this class, I get mugshots of everybody in groups of 4. I'm going to have to figure out a different way to do that so I can learn the names as quickly as possible. Probably it's going to come down to you giving a selfie in some way, shape, or form. If I'm walking around campus and I seem not to notice you, that usually means I'm lost in thought. You have to kind of break through that if you want to say hello, or just don't be offended when it happens. I tend not to be a morning person. My best thoughts are in the afternoon, the late afternoon in particular. That's when I do my most creative, most ingenious thinking. So I tend to be a little slow in the morning, a lot of grunts, a lot of groans. I don't drink coffee, so I tend to pick up speed as the day goes on. I don't really depend on caffeine all that much. I have a little clip of note cards, 3x5 index cards I keep in my back pocket. If I pull that out and start writing on that while I'm talking to you, it means I need to remember something. It doesn't usually mean or usually have anything to do with you. I say this because people and students have been, oh my God, he's writing something, bad about me down, or gonna note something, whatever. I did something wrong. No, it's just that's my auxiliary brain. It's in my back pocket. That's where I write things down to remember. If you have a question or concern, be direct in your question. I respond best to that. I don't do hints real well. You can ask any of my ex-girlfriends. I don't do hints real well. Be direct and kind of in my face when you're asking questions. I tend to talk fast. That's a detriment for teaching. That's just the way I grew up in New Jersey. We tend to talk faster because that's what we do. I grew up in Northwest New Jersey. I try to slow myself down in the lecture so words can sink in. I try to provide gaps for thinking and reflecting. But if I need to slow down, you need to speak up. So let me know. If I swear, which I probably will, I come from a family that considers cursing an art form. I apologize in advance for that. I will swear, it's just the way I speak. I apologize in advance for doing that. Honesty is very important. If there's a struggle that you're having in class, please be honest about it. Please be direct, and we'll get things where they need to be. I will try to be a man of my word. Sometimes there's just too much to do, but I will do my best. So hopefully we can maintain an honest relationship between us. The rest of the stuff you'll pick up as you go. So one of the things I want to make sure we have down as we go through here is plagiarism. This is a presentation put together by Professor Deshay. He has allowed me to use it in my classes as long as I give him the requisite credit and give credit where credit is due. Plagiarism, I take it seriously. If there is a plagiarism issue in class, I will report it. So Dr. Deshay got permission to use this comic in class. I know most of you don't know what comics are. They're the memes of, I guess, equal to the memes of this age. Back in the old days, we used to get newspapers. Always went to the comic page to see what was going on there. So Bill Ammond, I think that's how you pronounce his name, did this particular comic strip. I say it, no video games. But Mom, video games are educational. They teach kids to think fast under pressure. Mom says, how so? Well, take the video games or educational excuse I just invented. So the comic is published with permission for this demonstration. So is this plagiarism? Dr. Deshay, Professor Deshay, took his name, put his name on this. We pretty much say that is. We're not giving the author proper So what is plagiarism? If we look in your student handbook, the last version I looked up, and I'm sure it hasn't changed all that much if it's been updated, any written assignment submitted by a student must have original authorship. Representation of another's work as his or her own shall constitute plagiarism. So if you're sharing work, you're taking somebody else's work, submitting it as your own, I will turn it in. So if page, it looks, if it's on the page, it looks something like this. So under the code of academic honesty, we need the written stuff in there. So right here is basically the quote I pulled out. So Dr. Deshay asked, what about changing a couple words? He's going to take the words that were there and put his in place and say, hey, that's mine. Was that plagiarism? Yes, it is. Changing a few words doesn't make the work your own. Most of the stuff is there. Most of the stuff that is there is still the author's original work. We tend to think about the rule of taking three or more words in a row. When I did my dissertation, it was 5 words. If I used somebody else's idea, I needed to cite it. Give credit where credit is due. In academics and higher education, the ideas are the currency, the ideas are the things of value. We need to give credit where credit is due. So what about Dr. Deshay doing all his own words? So Dr. Deshay puts his name on here. Jason and his mom talk about a number of different things here. All Dr. Deshay's words. Is this plagiarism? Still plagiarism. What we're focusing on here is Dr. Deshay taking someone else's idea. Now, all the words were his, but the idea, the drawings were not. So you're saying the idea of those drawings, you're passing them off as Dr. Deshay's own, and that's not the full thing there. We're talking about stealing of ideas. So again, what the book says, taking someone else's work, ideas, whatever it is, and representing them as your own. So here's a real case that was in Dr. Deshay's classroom. Original text: in tests of 1,776 children in Australia, Ms. Rice and her colleagues found no correlation between the children's verbal abilities at 24 months old and the parents' socioeconomic status or their educational levels. I think that's Monastersky, 2008. The student wrote, Mabel Rice found out that there was no correlation between parental socioeconomic status and child's verbal abilities. According to all the results reported in the article, my conclusion, ... So this is a real world case. What do we have? We still have plagiarism. The student thought it was okay because they had moved the words around. But we're talking about ideas when it comes to plagiarism. Taking somebody's ideas. So it's plagiarism because she used the same words in a different order and she used Monastersky's idea without saying so. The Monastersky was the author of the article. Rice was the researcher he was talking to. We need to give that individual the proper credit. So student didn't mention, they mentioned Rice, but they didn't mention Monastersky, so that technically is plagiarism. The student, if you look at it, the student appears to have been saying that they talked to Rice directly, and that's not the case. So even though they didn't mean to, this was a plagiarized paper, and it got a 0. So that is the offense for every convicted plagiarism incident. You get a 0 on whatever that is. Test, assignment, whatever it is. we give you a 0 for that assignment after it goes through. It's got to get adjudicated by the dean, and if you feel necessary, it goes before the judicial board of the college. How do I use material properly? There are 3 things we can do. We can put that material in quotes, we can paraphrase it, we can summarize it. So, quoting someone else's exact words, changing the words around but keeping the idea intact, or summarizing an overall idea. All of these 3 methods also need a citation. So let's go through examples. How to quote. So we got the original text on the top. We've read that before. And you're saying right down here, yet there may not be a relationship with the parent's poverty and child's educational ability. So, and then we quote the upper article there, and then we make sure to give the credit to the original author. So what do we need to know about quotes? Quotes interrupt the flow of your writing, so use them only when exact words are important. You'll see that a lot on the scrolls on news channels. They try to get words exact when they're quoting somebody. Mark your quote to separate it from the text. So the key there is to do the opening and closing quote marks. Big quotes more than a sentence should be on their own and indented, and traditionally they go with a smaller font size. So if it's a big long one, we offset it, and again, we have to identify where the quote came from. There are a number of different formats. I don't care which format you do in my classes. Just give somebody credit where credit is due. Paraphrase. We again have that original text at the top there. We're saying right now we're going to rearrange the thoughts, change the emphasis, but we're not changing the idea. So in order to see if there was a relationship between a 24-year-old's verbal abilities and parents' income or education, Ms. Rice studied 1,776 Australian children, coming to the conclusion that no such correlation exists. And then we have our author here, Monastersky, 2008. So it's the same idea, different emphasis. It might be a little bit stronger here about who did the work, whereas we're focusing on here no correlation between those. So points about paraphrasing. So in this particular case, we used the idea, but we changed enough words so it's no longer a quote. So we don't have to put it in quotation marks or offset it or anything like that. The paraphrase allows us to make things read more smoothly and usually fit or flow better than quotes. By using a citation, Monastery 2008, the writer shows that the ideas aren't, in this case, Dr. Duchesne's, since he wrote that. Citations go after the paraphrase text. If you've got several sentences, you may consider summarizing. But again, it depends on what point you're trying to make. So here's an example of a summary. Ms. Rice found no relation between a child's verbal abilities and her parents' income. And then we have where that citation came from, Monastery 2008. So we don't need all the information. We're focusing on that there was no relationship. So again, the writer used the ideas but shortened them. If you're still using this citation to show where you got this from, somebody can go back and read the original if they want to. So citations. Proper citation is the most important thing between you and plagiarism. It's how you show somebody else's, you're using somebody else's work. Again, ideas are the currency of academia, higher education. Here, there's two that are mentioned here. The slide shows the APA format. There's the MLA. A lot of different places, journals, publications have their own style depending on what the needs are. I don't care what you use. It's more important that you cite than get your commas in the right place. You'll learn both formats in the English classes you take here. Keep your little seagull book, and so you can use that as you move forward. It's going to take a little bit of practice, a little bit of time to make sure your citations are correct. But again, try to do it whenever you're using someone else's ideas. If you need help, please ask, particularly if you're in the library. The reference librarians know how to do this. They get bored and they love to be asked questions. Also, the writing tuners in the Learning Center can help you as well. So what do we have for conclusions? Use citations freely, better safe than sorry. Remember, plagiarism is about ideas, not just the words. When in doubt, ask somebody if you think a citation is necessary. The gray area is what is considered general common knowledge versus some more specific idea. That's when in doubt, cite. Paraphrasing, summarize is better than quoting, but all three need to be cited. Here's our reference materials from Dr. Deshay's presentation, all the things that he used to get this done. Again, I've updated to the 2013 one. I don't know if there's a newer one. There might be than that one. So end of slideshow from Dr. Deshay. Consequences of plagiarism. We probably should mention those as we go through. If you are caught and we conclude that that is in fact plagiarized from another student, you will get a 0 on that assignment. I will do things in class that you might consider sneaky, but I try to penalize the people who are cheating off of other people. You'll see the methods I use as we go forward. If you don't notice, then you probably aren't plagiarizing. But that means there's often different tests, different quizzes that everybody has, so moving through. You get a 0 on that assignment, and we notify the dean. We provide evidence to the dean. The dean will decide whether or not it warrants a letter in your academic file. If the dean agrees with the assertion that I've made, the student, you'll get a letter in your file that says you're guilty of that. You have the opportunity to appeal if you wish. So that letter goes into your file. You get a 0 on the assignment. The second case, you will fail the class. It does not mean that you have to be twice in the same class. It could be one class here, you get your first one, you get your second one later on. That second one, you get a 0 in the class, therefore fail, and you get a failing grade every time after that. Some professors look in your file to see if you have one already. I don't do that. I decide whether it merits, or I can feel comfortable saying that yes, this is plagiarized, particularly from another student. Given that if it warrants it, I turn it in. The consequence is on you as to whether or not it is your second offense. I don't judge it that way. So again, that's on you, not on me. Don't make me have to do that. Related more to dairy nutrition, again, if you have any questions about plagiarism, please ask. I'll ask you if there's anything we need to review. We're talking about feed preservation for the next few weeks. Dry matters, making silage, making hay. When we're talking about feed preservation, there are two important concepts. One is controlling the bad microbes. What do bad microbes need on our dairy to do their damage? And we need to go through that concept. And then we have to think about microbes microbiology, we're going to very briefly dip our toe into that field. There are whole classes on campus that are devoted to that. Science of studying very, very small living things, microbes, molds, bacteria, viruses, all fit under that large umbrella of microbiology. So if we're preserving feed, we have to address the issue of bad microbes. Bad microbes are the ones on a farm that are doing the things that are going to cause damage, cause rot, do things that we don't want. There are microbes that we want to do good. They do good things for us. We want to encourage those. We have to somehow stop the bad microbes. And in order to think about that or address that issue, we have to figure out what microbes need to do the damage that they do. The first thing is they have to be present. If they are present, they have the opportunity to do something. Multiply, divide, grow. If they can do that, they'll do their damage. If they're not there, there's nothing they can do. If they are present, there are 5 things they need to get the job done. One is they need a source of food. They need a source of water. They need air, specifically usually oxygen when we're referring to bad microbes. Warmth. They go faster. They go, I think it's called the Q10 effect when I was going through early biology. The warmer things are, the faster things grow. In an environment, and they need an environment free of irritants and inhibitors, anything that's going to slow their growth or prevent them from living. So you need an environment that's free of those. So giving you this list, what's the key idea here? The key idea is that with this list here, if you take any one of these away, we don't meet the needs or the bacteria aren't present, you will stop the bad bacteria from growing and doing their damage. So the key idea is we have to take one of these things away. So what we're going to do here is some examples that we might find on a farm, stopping bad microbes. So we got a number of different processes or things that happen on a farm. Over here on the side, we got, are they present or not? Do they have food? Do they have water? Do they have air, warmth? And they're free of irritants and inhibitors. We start with hay up here. In order to preserve hay, to make it last, we need to dry it. We as humans use the drying thing an awful lot. Our dry foods in our cupboards and cabinets, they are too wet or too dry to rot. If they get wet, they will rot. So in order to preserve hay, to stop the bad microbes, what we do is take away the water. We dry it down. Taking that one thing away stops the microbes. Silage. We take a feed at the right moisture content and we pickle it. We make sure that it can be fermented correctly. In order to start a fermentation, we have to remove the air. The key to a good silage, the key to a good fermentation is to remove the air, specifically the oxygen. And we'll talk about the faster we do that, the quicker we get to a stable end product. With our silages, we are producing acids. The fermentating good bacteria are going to produce acids that are going to stop the bad microbes from doing anything. So acids are going to inhibit mold, yeasts, a number of other bad things from happening. So you're adding some lactic acid, some propionic acid, acetic acid, all will provide the irritants that stop the bad microbes. For looking at milk and preserving it on a farm, we may pasteurize it. So we're getting rid of the bad microbes. Whatever's present gets killed through pasteurization. We also holding that milk on the farm, we chill it down, we get rid of the warmth, and therefore the bacteria are slowed in their growth. If it was warm, that milk would be an ideal growth medium. The bad microbes multiply and grow and really destroy that milk in a very short period of time. We're talking hour, if that. We also use iodine and sanitizers to prevent the milk from being contaminated in one way, shape, or form. They kill the bad microbes and keep them out of the milk supply before they get there. Iodine on the teat end kills the bacteria that are going to cause milk destruction, kills them before they get there. Sanitizing the lines allows us to prevent any bacteria buildup in those lines. Looking at bedding under our cows. If we use sand bedding, we're taking away the food. There's nothing organic for those bad bacteria to grow on. We can also do the same thing with a mattress. Mattresses aren't very energetic. If we don't clean them on a regular basis, we can run into problems. But these are both ways we take away the food, the bad bacteria grow on and cause problems. We can keep our bedding dry. So we take the wet material, the manure, the urine, get rid of it. We clean those beds, keep them dry, and therefore keep the bad bacteria from growing that cause mastitis, that cause infections, all the things that will be a detriment to the cow. We can also lime our bedding. We have a irritant there. It's an osmotic irritant with the lime. It also tends to absorb water to remove moisture as well. So we have two things working to keep that bedding fresh, to keep that bedding from making the animals sick. If we have mastitis in one of our cows, an infection in the udder, we can use antibiotics to destroy those bad bacteria. Those bad bacteria are the antibiotics are an irritant to the bacteria and therefore either kill them or keep them from growing and multiplying. So we talk about feed preservation. It's about controlling those bad microbes. What are we going to do? In New York, we're talking about 6 months of growing, depending on where we are. We might be able to have animals outside eating stuff that's grown from May to end of October. We might be able to stretch it a little in either direction if we stockpile and things like that. But we're looking at half the year that we can grow good feed. If we can get through the winter, we as dairy producers need to preserve feed. So what do we generally do in the world? We tend to freeze stuff, but we can't find freezers big enough for most of our cows or herd. Salt, that was a way of curing before refrigeration, putting a lot of salt on stuff, desiccating it, drying it out, increasing the osmotic pressure to prevent the growth of yeasts and molds. You're only going to see that old timers when they're putting up wet hay. They tend to sprinkle salt on the bales to keep things from rotting or molding or burning up. But what we're going to focus on here is the drying and the pickling. So we dry, we remove the moisture, we pickle, ferment, create silage by first removing the oxygen, removing the air, so the bad microbes don't get a foothold, don't rot the whole stuff. And then we have the creation of acids, which provides an irritant to prevent further growth going through. So freezing, we're taking away the warmth. Salt, we're providing an irritant, so the environment is no longer free of irritants. Dry, we remove the water. Pickling, we first remove the air. So if you have any questions about that, please ask. We're going to today in lab sample as part of the feeder's job. The person who feeds the cows, there's a number of skills I believe that that person should have. I've done a lot of thinking about that since I came back to school. Uh, uh, Came back home from going to school. They taught me a lot about nutrition, but not about feeding. There were a lot of things I had to figure out on my own in that. One of the things was being able to do a good sample. Good sampling is worth tens of thousands of dollars, depending on the size of the herd. It would basically pay for your education over your lifetime if you did sampling correctly, and I'll prove that as the semester goes on. Analysis, frequency of analysis. How often do we have to sample? That's the first thing we usually have to figure out. You need to work with your nutritionist. The nutritionist needs to advise the client on how frequently to analyze ingredients and byproduct commodities. So you have the things you're feeding a cow. We need to balance rations. We need to know the ingredient composition, the how much water, how much fat, protein, carbohydrate, minerals, vitamins are present. And depending on what feeds we're dealing with, we will sample at various intervals. The frequency for feeds depends on the variability of the ingredients. The more variable the ingredients are, the more often we have to sample to get a feel for that noise. So our roughages or our forages have the greatest variability. Byproduct commodities that we buy, distillers grains around here, brewers grains from Anheuser-Busch, have a large variability due to they really don't care what the product, it's a waste product to them. They don't care too much. If we sample and keep track of things, there's an opportunity to create a nutrient composition log. Which fields are our best fields, have our highest protein, highest energy, versus our low quality fields, which one there, and then historically, if I do things right, where is my competitive advantage? Where am I good? What can I go through? How should I cheat my analysis in my ration balancing to minimize my risk to my animals? I want to make sure I get all the nutrients to the animals. How do I want to do that? And a nutritionist should be able to do that, statistically evaluate a range of samples, figure things out. When do we analyze feeds? We do that after harvest if we can. We need hay to cure down. Takes a while for that to happen. We need silage to be fermented. It's going to change its composition during the fermentation process. We want to know what's there after the fermentation. We test when and if we notice changes in the feed. If the feed looks different, has different color, different smell, different composition, we do a evaluation of that. Silages between the layers, between the cuttings. If we're sampling an ag bag, if we're sampling a upright silo, we're going to take things out in sequence, and we want to keep an eye on what those different fields are between the cuttings, between the layers, between the fields. We need to at least just for dry matter, if nothing else. So that's kind of the plant side. On the animal side, anytime something changes, whether we see a drop in DMI, that's dry matter intake, how much the animals are eating, if that changes or goes up for that matter. If we get a drop in milk production, we almost like, well, take a sample, we'll see what's going on. Change in body condition, change in health problems. Anytime our animals tell us there's something different, we need to listen to them and take a good sample. So taking feed samples, what are we trying to achieve? What are we trying to do? Lab analysis is done on about a teaspoon of dry ground material. So they take your sample, they get it to the lab, they dry it down, they grind it, and then they take a subsample of that and they run an analysis on it. The challenge is making that teaspoon represent possibly hundreds of tons of feed, depending on how often you sample. We've got these silos here will hold 1,000 tons. We may take 4 or 5 samples across the silo up at the dairy. So each of them maybe it has to represent 2,000 tons, 200 tons of feed. The feed samples, the numbers that come back, will determine how you spend money. If the feed sample comes back low in protein, you're going to have to buy more protein to make those cows productive. If it comes back high in energy, you're going to have to use less corn to get things there. I think about feeding our cows as investing feed into that cow. If we invest the feed into that cow, we hope that we get something back that costs or nets us more than it cost what we put in there. If we lose money putting feed into the cows, maybe we should have sold the feed to somebody else. We would have come out ahead. Again, that's not always practical. We can't, get rid of the herd this week and have it back next week. So the person on the farm who does the feeding is in the best position to take a good feed sample. And we'll talk about how to do that. I don't want feed companies taking feed samples. They don't do a good job. I'll tell you how to do it correctly. That feed sample will determine how you spend thousands and thousands of dollars. If I'm a feed rep and I want to sell you grain, if I want to sell you protein, I know exactly how to take a sample. If I have a feed sample that comes back 2 or 3 percentage points lower in protein, I will sell you more grain, and that's going to help my commissions. You, as a producer, need to buy only what you need to get the job done. The method what we'll go through today is listed here. We're taking feed samples. The first thing we do is we get a subsample of the feed that exists. We usually collect that in a large bucket. So a 5-gallon pail, 3-gallon pail, one of those things will help us get the job done. That subsample, it's best taken when we, at our dairy, when the face is, they deface the sample. And that's at 3, 4 in the morning. Most of you don't want to get up there, so we have a system in place where Steve will take those samples for us. And put the bucket aside. We take that bucket, we dump it on plastic. We have to mix up that sample, break up all the clumps, make sure that no particles are stuck together. Each feed particle needs to move independently. Once we have that broken up, mixed up, we're going to roll and quarter it. We're going to take the feed and we're going to move it around the plastic. Roll it around. We want it to tumble, not slide on the plastic. Once we've done that 3 or 4 times, we are going to take that feed pile and quarter it. So we divide it with crosshairs. We get rid of opposite sides. And then we keep a set of opposite sides and we roll it again. We keep losing half every time we roll and quarter until we get down to about a pint to a quart of material. Then we take that, we put it in a bag, we try to squeeze out the air. If necessary, we freeze the sample. We want to make sure that once we take that sample, it does not change from when we've taken it till it gets to the lab, which may take 2 or 3 days if the mail is working correctly. And we mail on a Monday or Tuesday to get it there by the Wednesday, not on a Friday, so it sits in the post office for 2 days before it gets delivered on Tuesday. We want to make sure those wet samples remain cool all the way through. That's not a big issue in the wintertime, but in the summer when we're mailing samples, there can be significant degradation. So we got to focus on getting the air out, keeping the sample cool to get it to the lab. So we'll show you how to do this in lab, and you're going to be collecting a sample that you're going to run a dry matter on next week. So that's it. Hopefully this time will work. and we'll take it from there.